Today's lesson deals with some things that we've already actually talked about in terms of the octet rule. The octet rule, remember, is that when bonds form and when we draw these Lewis electron dot diagrams, that we try to draw them in such a way so that every atom ends up with 8 electrons. Okay? But there are some times when that just can't happen or just doesn't happen. So one of the times that happens, and again, we've already seen this a couple of times, is sometimes you're going to have what's called less than an octet. And if you have less than an octet, it means that that molecule, or that atom, will not have 8 electrons around it. And we already saw that, for example, with water, that hydrogen clearly does not have 8 electrons around it. Okay? And the only other one that you need to be familiar with is the element boron. Okay, boron, if you think about boron, boron is 1s2, 2s2, 2p1. So boron only has 3 valence electrons all total. So in order for boron, like in BF3, in order for boron to be able to have 8 electrons, you would need to make a double bond with one of those fluorine atoms. However, boron simply doesn't have it. If you think about it, boron has these 2 electrons and that 1 electron that can form bonds, and that's it. It doesn't have that 4th electron that it could use to make that 4th bond and therefore make it have 8. So boron is an example of a time when you will not have 8 electrons. So BH3 only has 6. And I down here I do talk about BF3 as well. There again is BF3. You don't make a double bond on boron. So hydrogen gets that 1 single bond, that's it. Boron gets 6 dots around it, that's it. Don't ever make a double bond with boron. Okay, sometimes you may have what's called more than an octet. And again, we've seen this as well. For example, on XeF4, you end up with, that has 36 electrons. So you use 32 with the fluorines, but then what happens is you have 4 left over. Well, what's the rule say? When you have some left over, you must place them on the central atom. So clearly, that xenon has more than 8 electrons. It actually has 12. So sometimes, with those lone pairs, you're going to end up having more than 8. Sometimes, you just have more than 4 bonds, like SF6, no dots on the central atom, but look at the number of bonds it makes. Yes, and all 6 of them are bonded to the sulfur, and yes, this is a real compound. This is called sulfur hexafluoride. And that compound SF6 is actually really interesting because it basically does the opposite of helium, in that if you can breathe it in, and then when you breathe it back out, because it's so much more dense than air, as opposed to helium, which is less dense than air, it actually makes your voice really, really deep. So you talk and your voice is very deep when you breathe out sulfur hexafluoride. Okay? Either way, you will have cases where you're forced to have the central atom having more than 8 electrons. Again, that's fine, because remember, we just follow the rules. We put 1 in the middle, we put everything else around it. If electrons are left over, we place them on the central atom. Notice no double bonds on those, because we only use double and triple bonds when the central atom doesn't have 8 electrons already. Okay? And then the last one, this is kind of the strange one here, is every now and then, in again, rare cases, the total number of electrons may not add up to 8. And I shouldn't even say 8. The number of electrons may be just basically an odd number. Okay, for example, on NO2, nitrogen has 5, oxygen has 6, there's 2 of them. That equals 17. So you're like, okay, I got 17, I'm going to do this. I'm going to I'm just following the steps, Mr. Johnson. I'm just doing what you told me to do. Okay, and now if electrons are left over, place them around the central one. So I'm going to I've got 1 left over, right? I have 17, and I had used 16, so I had 1 left over. Okay, am I done? Almost. Remember, in this case, when you have an odd number of electrons, you try to get as close to 8 as you can for all of them. But if you can't, again, you just get as close as you can. Okay, you're not going to get to 8 on all of them because you have an odd number. So this nitrogen right now has 5 electrons. So we're going to try to at least get it closer. So we're going to bring 2 electrons in and make a double bond. Can you bring 1 electron in and then make them? No, you can't. Okay, when you bring electrons in to make a bond, you got to use 2 electrons for that. Okay, and so that's it. That's all you can do. Okay, even on nitrogen monoxide, NO, 5 plus 6 equals 11. So there's our 8. So 9, 10, and then 11. So again, same thing. That nitrogen only has 5. So I'm going to take 2 from the oxygen and put that double bond in there as well. Now, could I also have done it where the single electrons on the oxygen? Of course I could have. Okay, and we're going to talk about that actually in our next video. One of these two is the better representation of the molecule. Okay, and we're going to talk about how we know it. But if I were to say draw the Lewis electron dot diagram on a test, you could draw this one or you could draw this one. It wouldn't matter. Both of those would be considered correct. All right, so let's look at some examples here. SF4 has 34 electrons. So we're going to put the 4 fluorines around the sulfur. We're going to put the 6 dots on the fluorine. And that's 32, so we have 2 left over. So those extra 2 go on the central atom. That is an example of an expanded octet where that has more than 8 electrons around the central atom. Okay, letter B. So here's an example of if I give you a bigger molecule, I'll show you what the structure looks like. So this goes HOOH. This is actually the chemical formula of hydrogen peroxide. So the stuff you put, if you get hurt, you put it on your ouchie and it makes it better. We do have 1661. We have 14 electrons all total. We've used 6. Remember, no dots on hydrogen. So there's 4 more, there's 4 more. There's all 14 of them. All of them have 8. The hydrogens have 2. We're good. That one is not an exception to the octet rule. Okay, PS2, kind of reminds me of the old PlayStation days, huh? 5 plus 12 equals 17. So this is an odd electron molecule here. So we're going to have P and then the 2 S's. And again, just following the steps, right? So there's 16 electrons. We have 17, so we've got 1 left over. I'm going to put that on the P. That has 5 electrons, so that means I'm going to take 2 from the sulfur, and I'm going to make a double bond. Okay, and so that, remember what we talked about in our last video, we talked about resonance structures. This molecule right here would have 2 different resonance structures. One with the double bond on the right, one with the double bond on the left. Okay. All right, and then letter D, 6 plus 21 equals 27. So again, another odd electron molecule. So 8 times 3, so there's 24 electrons. So I do have 3 left over. So this is one that's a little bit interesting in that we're going to put a pair on there. So now I still have 1 left over. So this is interesting in that not only does it have an odd number of electrons, so that oxygen has the odd number on it, it also has more than 8. That oxygen ends up with 9 technically. Okay, so that's kind of 2 of the exceptions in one drawing, which again, I'm just following the rules. Electrons are left over. I'm told to put them on the central atom, so I do. Okay, and then our last one with boron. Remember, we just talked about boron. Even though you're really going to want to be tempted to put those double bond to the boron, that's it. Stop right there. Okay, as soon as you see boron, just remember it only gets 6 electrons. It only has 3 valence electrons, so it can only form 3 bonds. You cannot bring these 2 electrons in here to form the double bond because boron does not have it. Boron does not have that 4th electron to make that last bond. Okay. And that's it for the exceptions to the octet rule.